Hello guys, this is CodeNCode and this is video lecture for the problem rod cutting problem, and we'll be solving it using dynamic programming. So the problem is you are given a rod of length n and you want to cut and sell the pieces in such a way that maximizes the total money you get. Uh, a piece of length I is worth pi units of money. So this is the price chart. So if you sell a length 4 rod, then it will give you a profit of unit 9, I mean 9 unit of money. And if you sell length 6 rod, it would give you 17, and so on. So if you have a rod of length 3, these are the all 4 possible configuration. You can either sell it by pieces of 1 1 and 1, so total profit you will be getting is 3. You can sell it by pieces of 1 and 2, so 1 and 2, so total profit you will be getting is 6. Similarly for 2 and if you sell the whole length 3 rod, which will give you total 8 unit of money, so profit would be 8. So the maximum out of all of these configuration is 8. So for input n is equals to 3, the output should be 8, which indicates the maximum profit that you can achieve. Of course, the reference for this lecture will be CLRS book. Now the problem to be discussed, there are two different problems. First, for given input n, you only need to print the maximum profit that you can achieve. Second, you actually have to print the length that you will be selling. So if you are selling for n is equals to 4, if you are selling 1 1 and 2, so you have to print 1 1 and 2, that I am selling 1 and 2, and this configuration will give you the maximum profit. So these two, this is the first problem that we'll be solving, and then this problem can be actually solved using a simple modification to the solution of the first problem. Now the question is, what is the maximum profit that we can achieve? Basically, we are going to tackle the first goal. We are going to achieve, the first goal. Now how will be finding out the maximum profit that we can achieve? Of course, this is a dynamic programming lecture, so we'll be using dynamic programming to find the maximum profit that we can achieve, and there are two different approaches, and we'll be discussing both of them in detail. So we'll be studying recursive, that is top-down approach, as well as iterative, that is bottom-up approach. In the future, I'll be referring using these two words. I'll be referring recursive or iterative because I believe these two are more related to the implementation. Recursive approach, basically the top-down approach, you saw the algorithm is applied using recursive methods, recursion, and the bottom-up approach is implemented using iterative iteration, basically the for loop, and the for loop. So these two names are more related to their implementation. That is why I usually call recursive or iterative method. Now, so this is the same problem statement. This is the price chart, and now if you see, for n is equals to 4, these are the 8 different configuration possible. You see, if we sell the whole length 4 rod, this would give you a profit of 9. Similarly, if you sell 1 and 3, it would give you profit 9, and so on. The maximum profit you see that you can achieve is actually 10. If you sell length 2 and length 2 separately, then you can get a profit of 10 unit, and that is the maximum, and that is what we'll be printing, right? Now the first question that should come in your mind is, how many different configuration are possible for a given n length rod? For example, length 4 rod, we have these 8 different configurations. So for a given n length rod, how many different configurations are possible? Because if we know how many different configurations are possible, then we can apply brute force approach to find the answer for rod of length n. If the total number of configuration are not too much. So for length 4 there are only 8 configuration, so I can go through each of them one by one and find out the maximum, right? But it turns out that the total number of configuration are 2 raised to power n minus 1. And why is that so? See, if you have a rod of length n, then there are n minus 1 cut points. So for length 4 you have this 3 different cut points. So for length n rod you have n minus 1 cut points. Now for each cut point you have two choices, either to leave it as it is or make a cut there. For example, in this configuration, first cut point is remain intact, we haven't cut there, but in the second configuration we have made a cut on first cut point. So for each cut point you have two choices, either to cut it or do not cut it. So there are n minus 1 such cut points. So the total number of configuration, if you apply basic combinatorics, would be 2 raised to power n minus 1, right? Two choices for each, and there are n minus 1 independent choices. So the total number of configuration would be 2 raised to power n minus 1, and that is exponential. So basically for n is equals to 11, we would be having 2 raised to power 11 minus 1, that is 2 raised to power 10, that is 1024 different configuration. So if length is 100, you can imagine 2 raised to power 99, and that is just too much. Of course exponential algorithms are just too much. So now we know that total number of configuration are exponential, and we cannot apply brute force because there are exponential number of configuration. So you can't just go to each configuration one by one and find out what configuration gives you the maximum profit. So of course the brute force approach is not going to work for greater values of n, and that is why we are having a DP solution which will eventually give you n square solution. Now in this lecture we'll be discussing bottom-up approach, that is iterative approach. In the next lecture we'll be studying the recursive approach, and in this lecture we'll be studying the bottom-up approach as well as the proof of correctness of that approach, that why that algorithm works. I mean, yes, the proof that why that algorithm is correct. So P array is actually your price array. This start from index 0, so price of length 0 will be 0, of course. This is price of length 1, 2, 3 and 4. DP of I would store the maximum profit of length I rod. So if you want to find out solution of n, we would start from the very basic, we would start from the very base case. When you are working with bottom-up approach, you would start from the base case. So we'll start from base case and then build the solution one by one. So think about the base case. What would be the base case? So whenever you are solving with bottom-up approach, always think about the base case, and that is where you start. So what would be the base case? The base case would be the minimum input for which you have to solve the same problem. So of course the minimum input for which you need to solve this problem would be length 0. If the length is 0, the the maximum profit you can achieve would be 0, right? So of course DP of 0 would be 0. This was the base case. Now for the next, so if you want to find the solution for length n, we would start from length 1, 2, 3 dash 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 till n. We are basically building the solution from base and we are going up, and that is why this is known as bottom up. You start from the very bottom, basically the base case, and then go up and up. So we'll start, we have taken care of the base case. Now from 1 to n, we would find out solution of each I. So for and this is how the process would go. For length n rod, we will have n phases. In each phase we will divide the whole rod in two parts. For example, if the rod is of length 5, there will be 5 phases. In each phase we would divide the rod in two parts, the cut part and the remaining part. So in phase 2 I'll be dividing the length 5 rod in two parts, length 2 rod and length 3 rod. Length 2 would be the cut part and length 3 would be the remaining part in phase 2. The cut part we are going to sell completely as it is. So if I have cut a length of I have cut a rod of length 2, if the cut part is of length 2, then I'll be selling length 2 completely, so it would give me profit of P of 2, right? And then for the remaining part, which is 5 minus 2, that is length 3, I'll be trying to find out what is the maximum that I can achieve with length 3 uh, rod. Basically, I'm allowed to further decompose length 3, the remaining part, but the cut part I'll be selling it completely. So in the ith phase, cut part would be of length I and remaining part would be of length n minus I. So the cut part I'll be selling it completely without decomposition, while the remaining part I can decompose it further. So this is how the algorithm will proceed. So since we need to find dp, we need to run algorithm, we need to find the maximum profit of each length from 1 to n. So there are I'm running this phase part, n phases for n length, length 1, length 2, length 3 dash dash. Since we need to build the solution up to n, so we would start from 1. For each length we'll be calculating the maximum profit. So for ith length, profit would finally hold the maximum profit you can achieve for length I rod. So since we need to calculate till n, that is why we are running a loop from 1 to n, right? So for each length we are initializing the profit with 0, and now we are running, since we are calculating for length I rod, we will be having I phases. This represents the phase. Don't worry, why this formula works, I'll be explaining you in very detail. Basically, I'll be giving you the proof why this is a correct solution. So we are having I phases because we are we are having I phases because we are calculating maximum profit for length I, right? So you initialize the profit with 0, run I number of phases. In each phase, what you do, you divide the whole rod in two parts, the cut part and the remaining part. Cut part you sell completely, that is why it will give you the profit P of j, and the remaining part you are allowed to decompose further, and the remaining part would be I minus j. And since the remaining part you are allowed to decompose further, now the question is, what is the maximum profit you can achieve with this length rod? And that is actually dp of I minus j. This length means I minus jth length, and dp of I minus j actually contains the maximum profit you can achieve with length I minus j, and that is why we are adding dp of I minus j here. Finally, after running all of the I number of phases, dp of I you can assign with profit, because profit will contain the maximum profit you can achieve. Now if I show you the example test cases while running this phases, I'm going to explain the example test case taking n is equals to 4. So I'll be running, for n is equals to 1 I'll be running one phase, for n is equals to 2 running two phase, and so on. Basically I'm dry running this algorithm. If you want to skip this part, you can skip. So for n is equals to 1 we are only going to have one phase. For phase 1 the profit you can achieve is 1/2. For phase 1 j would be 1, so p of 1 plus dp of 1 minus 1, that is dp of 0. dp of 0 is 0 and p of 1 is 1, so 1 plus 0 is 1. So in first phase the profit is of 1, and for n is equals to 1 there will be only one phase. So after that you initialize dp of 1 to be profit, which is 1. So dp of 1 is equals to 1. Now for n is equals to 2 there are going to be two phases. In phase 1 the profit would be profit of 1 plus dp of 2 minus 1, which is 1. So p of 1 plus dp of 1, p of 1 is 1, dp of 1 is 1, 1 plus 1 2. So in first phase the profit is 2. In the second phase profit comes out to be 5, so profit would be updated to 5. Why? See, for any, when j is equals to 2, p of 2 plus dp of 0, p of 2 is 5, dp of 0 is 0, so 5 plus 0 5. Maximum of these two phases is 5, so of course dp of 2 would be 5. Similarly for phase 3 there will be three phases. In phase 1 p of 1 plus dp of 2, p of 1 plus dp of 2, so it is going to be 6. In phase 2 it would be p of 2 plus dp of 1, so p of 2 plus dp of 1, again 1 plus 5 6. Now p of, in third phase it would be p of 3 plus dp of 0, p of 3 is 3, dp of 0 is, sorry, p of 3 is 8, p of 3 is 8, dp of 0 is 0, so 8 plus 0 is 8, so the maximum of all of these phases is 8, so of course dp of 3 would be updated to 8. Same goes for fourth phase, you can check it out yourself. So maximum you can see is 10, so dp of 4 would be updated to 10. So this is how this algorithm runs. Now the question is why this formula works. We know that there are 2 raised to power n minus 1 number of cases for n length rod, and for n length rod we are only running n phases. How is it covering in linear time the total number of exponential configuration? How is it able to cover all of the exponential number of configuration, or yeah, different configuration in only linear run? And I'll be explaining you like this. See, for n is equals to 4 there will be 8 number of configuration, right? Because 2 raised to power 3 would be 8, so these are the all 8 configuration. Here there is no cut, here there is one cut, at this place, at this place, at this place. Here we are having 2 cuts, and here we are having 3 cuts. So in total we are having 8 different configuration. Now what you can do, if you find out the maximum of all of these, then that would be the maximum profit that you can achieve with length 4 rod, right? Because now you are going through all of the configuration one by one, but that is time consuming because there will be exponential number of configuration. But it is 100% true that if you find the maximum of all of these configuration, that would be the maximum profit that you can achieve, right? Because you have gone through all of the configuration one by one, so that is 100% true that you would get the solution. But sorry, now what I have done, I have grouped them together in and different groups, basically 4 different groups. These 4 are in group 1. I have also given the same color, so you know that I have only rearranged them. These are all of the same configuration as this, so these 4 belong to the first group, these 2 belong to second group, this belongs to the third group, and this belongs to the fourth group. Now there are 4 groups because n is equals to 4. Now can you find out, or can you at least see what is the reason when 2 elements are put into the same group? Think in terms of 1 2 3 and 4. Why these 2 are in same group, or why these 4 are in same group, why these 2 are in same group, and so on. Just pause the video and think for a second. So the reason I have put these 4 together is the first cut. If you see in all of these 4 configuration, the first cut is of length 1, right? Here the first cut is of length 2, the first cut is of length 3, and the first cut is of length 4. Here you can see the first cut is of length 1. In this matter, the first cut is of length 1 and the second cut is of length 3, but it doesn't matter what is the second or the third cut, because here the second cut is of length 1 and the third cut is of length 2, but it doesn't matter. The only thing that matters is the first cut. So the first cut is of length 1 for the group 2, the first cut is of length 2, similarly for 3 and 4. Now how this is going to explain? Now again, if we go through all of this configuration and find the maximum, if we take the maximum profit out of all of these, that would be the maximum profit you can achieve from length 4 rod, right? Now since I have rearranged them into the groups, so the maximum of suppose g1 is x1 is the maximum. Since this is the maximum, let's call them m1. So suppose m1 is the maximum of group 1, m2 is the maximum of group 2, similarly m3 and m4. So the maximum you can achieve, maximum profit you can achieve of length 4 would be maximum of m1, m2, m3, m4, right? Because m1 is the maximum profit you can achieve from group 1, similarly m2, m3 and m4. So the solution would be maximum of m1, m2, m3, m4. Now if we can calculate m1 in constant time, similarly m2, m3 and m4, so calculating maximum of these 4 will be done in linear time. If you can calculate maximum of all of these 4 in in constant time, like in one operation. There are 4 configuration, right? But still I want you to calculate the maximum of all of these 4 configuration in constant time, that is in single operation. Can you do that? If we can do that, then we know even though there are exponential configuration, there are only n number of groups, that is linear groups. If I can find the maximum of each group in constant time, then I can take maximum of all of the groups in linear time, right? Because all I have to do is initialize result with 0, result is equals to max, and then go through all of the groups one by one. Result is equals to maximum of result comma m1 mi, so it would give you the maximum of all of the n groups, right? In that way you are able to achieve the maximum in linear time. Now the question is how to find the maximum of a group in constant time, and this is how. See, the in group 1 there is one thing. First of all, we need to find the maximum of all of these 4 configuration for group 1 to calculate m1, right? In all of these 4 configuration, one thing is common, and that is the first cut. The first cut is of length 1, so of course this would give you profit p1, right, for all of these 4 configuration. Now since p1 is common to all of the values of this and this and this and this, so this would not help you to calculate maximum. When you have n number of elements and all of them are having certain constant part, right? The first cut is actually constant, and then variable part, the remaining is actually the variable part. So the maxima, if you want to find over all of the group, is determined by only the variable part. So just remove the p1 because this is constant to all of the 4, and to find the maxima you have to find the maxima of variable part. So g11 is actually the first variable part of g1, g12 is second variable part of g1, similarly g3 and g4. So basically the maximum of first group would be p1 plus max of this, maximum of the variable parts of all of the remaining configuration, all of the configuration of g1. Now can you find out the relation of the variable part of these 4 variable part? One thing you can note is that all of the remaining part is of length 3, right? That would be because all of the cut part is equal, so the remaining part would be equal as well. And the remaining part, you see, all of the remaining part is of length 3, first thing. Second thing is that how many different configuration are possible for length 3 rod? The answer is 2 raised to power 3 minus 1, basically 2 raised to power 2, which is 4. And as you can see, these represent the all 4 possible configuration for length 3 rod. Basically now you need to find, this is actually the maximum of the different configuration of length 3 rod, right? And how you can find the maximum, I mean where you have stored the maximum of maximum you can achieve with length 3, that is your dp of 3, right? Because dp of 3 stores the maximum profit you can achieve using length 3, and that is exactly what we want here. We want what is the maximum. This actually wants the maximum of the maximum profit you can achieve using length 3 rod, and that would be dp of 3. That is why we are having p1, and this expression would be actually dp of 3, basically pi plus dp of n minus I. Now this is for the first group. Now for the second group, the maximum of second group you can calculate using p2 plus maximum of g21 and g22. G21 is the variable part and g22 is the second variable part. So you need to find the maximum of these two, right? Because p2 would be constant in both of them. I want to find the maximum profit of g2, and that would be done using p2 plus g21 and g22. G21 and maximum of g21 and g22 is basically dp of 2. Why? Because the remaining part, variable part, is of length 2, and we need to find the maximum profit you can achieve using length 2, and that would be dp of 2. So this part is actually dp of 2. So you can see this is p of I again plus dp of n minus I. Similarly for length 3 and 4, this is true. So now you see, when you are going through all of the phases, you are actually going through all of the groups and you are taking maximum of all of them, and this way you are making sure that all of the configuration are actually being covered, and that is why we are having this formula right there. This, you are having n phases. In each phase, what you are doing, you are actually finding out the maximum of each group, and this actually gives you the maximum of jth group. And since you are going through all of the groups, that means you are going through all of the configuration, and since you are going through all of the configuration, that means this profit actually, after running through all of the configuration, contains the maximum profit you can achieve for length I, and that is why this formula is correct. So now I'm assuming that you know why this formula works. I don't think most of the people will tell you why this formula works. The best that most people do is tell you that you can solve this problem this way, but why this way works, most people don't tell you. So I just wanted to tell you why this. In fact, in most of the videos, in fact in all of the videos, my main thing is that I want to tell you why this works, so that you know, and your thinking ability actually builds upon these thinkings, so that in future, if there is certain variation of the same problem, because there are many I've seen, for this they take the same cliche dynamic programming problem and then they turn it into an interesting problem by simply changing certain parts upon which the original problem was built. So if you know how the solution was built, you can think about how you can modify the algorithm to solve a problem which is a simple variation of the cliche DP problem. So again, before we leave, let's visit the Unacademy. So Unacademy has launched a competitive programming course where you get these perks. First, you get to learn from the experts. Experts are like the guys who are IOI medalists and ICPC finalists, and the guys who have worked with companies like Google and Microsoft and companies like that. All of the courses are well structured, and you get to get live sessions where you can interact with the TAs, and if you have any doubt you can ask them in there, and they'll make sure that your doubt is clear. And of course, there are many, you can get the subscription, and the subscriptions are of 1 month, 6 month and 12 month. And as you can see, if you use my code, you get 10% off on 6 or 12 month course or subscription. But for 1 month, when you need to try, initially it is like 6,000, but when you apply the code, you get to get the 1 month subscription only for 9.99. So if you want to check out whether the subscription of this competitive programming course provided by Unacademy is worth investing your money or not, of course you can always go for the 1 month subscription. So if you really want to invest your money for competitive programming and you want to learn from experts, and you can afford, you can go with first 1 month subscription, and if you like the way they are teaching and you are able to understand things, of course you can go for the 6 or 12 month subscription. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.